Okay, this video is going to introduce, I'm going to call this skill number 4 and skill number 5, which is adding and subtracting rational expressions where you already have a common denominator, or here the common denominator would just be differing by a factor of -1. So once again, I've taken the notes that I presented and I've copied them on separate paper so that I can work a little bit bigger, so I can write a little bit larger. So I'm going to start with skill number 4. And I've got both problems copied on a separate sheet of paper. So let's go ahead and get started. So I have skill number 4, and I'm adding rational expressions together where I already have a common denominator. So the first example is, here I've got the first example copied. You can see that they both have a denominator of x plus 9. So my only excluded value is going to be -9. X cannot equal -9. And to go ahead and get started, I'm going to copy the both numerators. I'm going to create one expression. I'm going to combine the numerators over this common denominator, and then I'm going to analyze the new numerator to see if it can be factored for simplifying. So here I see that I've got a GCF of 2x, leaving me with x plus 9. So I have the common binomial factor of x plus 9 in both numerator and denominator. It divides out of the problem, and the simplified expression is 2x. That would be my simplified expression. Let's look at the second problem. So once again, notice I've got the common denominator in both expressions. My only excluded value is positive 12. So I'm going to recopy the problem as one expression. And I'm going to factor that numerator, the difference of squares. And here's my denominator, x minus 12. I see that I can divide out x minus 12 top to bottom, and my simplified expression is the binomial x plus 12. That's my simplified expression. And let's move on to what I call the tricky problems. So these are the problems that differ by a factor of -1. So I'm calling this skill number 5. And you can see all of the examples that I've made up here, each denominator differing by that factor of -1. So they're the binomials where the terms have traded places and they're connected by subtraction both times. So let's go ahead and look at these slowly together. So I've got the first set copied. And let's just go through these quickly, or let's just go through these slowly, but it's actually a pretty simple process. So what happens here, the common denominator, I always default by letting the first fraction be the common denominator, but it doesn't really matter. But the process that I like to use, letting the first denominator be the leader, the common denominator, actually is a little bit cleaner. So what I'm going to do, I'm going to say that my LCD here is going to be x minus 7. So that means that this second expression needs to have a denominator of x minus 7. So if I introduce that factor of -1 into the problem, what it's going to do is introduce an additional negative sign to the problem. So an easy way to do this, I've got a numerator of 3x. I'm going to go with a common denominator of x minus 7. By introducing this negative factor right here, it changes the original operation to a negative sign. And I can write this as one expression. And instead of adding 3x, and instead of thinking of my numerator as 3x plus 21, I think of my new numerator as 3x minus 21. And the subtraction is a result of introducing this negative sign here. So then to carry on with the problem, I now have a rational expression with the denominator of x minus 7. I'm going to reverse distribute out a 3 in the numerator, seeing that I've got that common binomial factor of x minus 7 top to bottom, and my simplified answer is going to be 3. And I'm going to do all of these with you, and I'm going to use the same process each time. So analyzing the second, I can see that I've got x minus 2 and 2 minus x. So my common denominator, I'm going to default to the first. I'm going to say that I want my common denominator to be x minus 2, Notice that this is a subtraction. So I'm introducing an additional negative sign into the problem, which is going to turn this operation into an addition. So to express this as 1, I'm going to have a denominator of x minus 7. I have my original numerator of 10, but now instead of having 10 minus 18, it's going to become 10 plus 18. And then my expression is going to be 28 over x minus 2. And I can't simplify that down. We've already discussed that in previous videos. The 28 and the 2 are off limits for simplifying. Let's go on. Let's look at the next problem together. So here I've got 2x minus 3, 3 minus 2x. If I'm going to go with 2x minus 3 as my common denominator, that means I would need to introduce that factor of -1 into the second ratio. And the result of that is going to be changing the operation between the two expressions from subtraction to an addition. So now when I rewrite these as one expression, my denominator is going to be 2x minus 3. And my numerator is now going to become 7 plus 2 rather than 7 minus 2. So my simplified expression is 9 over 2x minus 3. And then once again, the 9 and the 3 are off limits for simplifying because the 3 in the denominator is actually 2x minus 3, and we've already discussed that in previous videos. So carrying on with the process, I'm going to use the same process in all of these. Here you can see that they're differing, the denominators are differing by that factor of -1. The two expressions are being subtracted. So if I were to think of letting the first expression take the lead and become my common denominator, I would introduce that factor of -1 into the problem. My denominator is going to be 4x minus 1. My numerator is now, instead of thinking of my numerator as 5 minus 3, my numerator is now going to be 5 plus 3. And my simplified expression is 8 over 4x minus 1. Same process. I now have double variables, and I didn't list excluded values. So here, x would not be allowed to equal positive 1 over 4. And just to go back, I didn't do that in my other problems. I was more concerned with the other issue. In the second problem, x would not be allowed to equal 2. And then x here would not be allowed to equal positive 3 over 2. Now moving back to the problem where I was. To apply the same logic, here I've got x minus y, y minus x, differing by that factor of -1. If I choose to let x minus y be the common denominator, then I need to introduce this factor of -1. And the way that that result is going to be felt in the problem, instead of adding the numerators together, I'm going to subtract the numerators to subtract the second numerator from the first numerator. That's where I'm going to deal with that additional negative sign in the problem. And here I need to now GCF factor the numerator. And I see that I have the common binomial x minus y, which is going to divide out of the problem, leaving the simplified answer as positive 5. And here with a problem like this, we're not going to do multivariable problems with excluded values in Algebra 1, but if I had to list the excluded value here, I would just simply say that x is not allowed to equal y. But we're not going to do much of that, but I like this problem, so I wanted to do it in the video. But the excluded value would be listed in this manner. And then let's look at the last example. And so here I'm adding the two together, but when I introduce that negative sign so that I have a common denominator of x minus 3, I'm now going to have my new numerator is going to be expressed as 4 minus 2, and my simplified expression is going to be 2 over x minus 3. And then for this particular problem, x is not allowed to equal positive 3. So for a practice set with this, I've just chosen, once again, the little puzzle because the answers are given for you and you know early on if you are not, if you have some problems and you need to seek some help if you can't find your answers. I think that the first column is pretty self-explanatory, should be fairly simple, and the second column, just whenever you get into the problems, I don't know if I did any like this. Let me go back and look. I don't think I have one exactly like, actually, no, I take that back. We did do a problem. The problem that I did right here is exactly like number 4 in the puzzle. So you have the skill set that you need to get through these. Yeah, numbers 4 and 5 would be modeled from a problem like this. So you can see that you have a common denominator in each of these. You're simply going to combine the numerators together. And if you need to factor the numerator, then go ahead and factor the numerator and simplify down. And I think before I leave the video, I think I'm going to do number 10. Looking at this, let's do the column back here. These are a little bit more, have a little bit more going on. Let's do at least one of these. And let's do number 10 on the video. And let me get this copied. And then as I copy this, I'm going to copy this, and I'm going to factor that denominator as I copy this just for the sake of time. So this is going to be x minus 5, x minus 4. And here I've got 3x. They both have a common denominator. I'm just going to copy it in its factored form. I'm going to write the ratio 3x minus 12 in my new numerator here, just for the sake of time and space on the video, and I didn't space that out very good, did I? I'm not asked to list excluded values in this particular homework set, but I'll go ahead and do it just to be thorough. As you can see here, you're just simply asked to combine these and simplify the expression, so don't worry about listing excluded values in the homework set. And here, the way that I would carry on with this, I would now do a GCF factoring in that numerator. And then I would look for the common binomial factor. And then the answer that you're going to be looking for is this. That's going to be your simplified answer. And I will stop the video here.